All right, everybody, welcome. If you didn't join us for the Q&A before this, then we missed you and we recorded it, so you can get that. I'll send that link out to everyone. But today we're going to be talking about how to kind of get your biotech class off the ground in the first few weeks of school. So if you are a new teacher or even a more experienced teacher kind of looking for more ideas, because you're always trying to improve and get better, I think this will be a really good webinar for you. This is going to be presented by Kirk, Brown, and Stan Hitomi. Kirk is the author of our biotechnology textbook, and Kirk and Stan together are kind of the voice in the hands of Bio-Rad. So if you've ever had the chance to see those biotechnology skills videos, that's these guys, right? So I'll let them introduce themselves a little bit more, but welcome. We're glad you're here. And I'm monitoring the chat. Aaron Callis is monitoring the chat. So if you have any questions, go ahead and put them in there. We'll interrupt as needed if there's something burning that we want to ask, and then there'll be time at the end as well. I'm actually going to go over the objectives and then I'll turn it over to them. So we're going to look at, again, like I said, these first days and weeks of the course. Actually, Stan, do you want to go over these?
Yeah, sure, I can do that.
Yeah, I'll let you do that. Sorry.
Yeah, so our primary focus coming into this webinar was to address that need of teachers, especially the ones that are entering the field of teaching a biotech class for the first time. So what we've basically done is taken Kirk Brown's first 3 weeks and laid those out as kind of the foundation. But the major objectives that we're going to hit, and these are kind of woven throughout the presentation, is that big one is, what kind of shifts do you need to make in your teaching when you're teaching a biotech course versus a traditional biology course? There's obviously, those of you who have been in it know there's an extremely different focus. Secondly, and this is a target of success for all teachers in any course at the beginning of the year, and that's establishing routines. And specifically in this talk, we're going to talk about those specific routines that are directed in the biotech class. And then instructional strategies, we'll weave those throughout. Managing prep. This is a big one, right? You're prepping a lot of material, and of course, within the same amount of time you always had before. And so Kirk, who taught probably one of the most comprehensive biotech programs that I've ever seen, has many different strategies, and I can chime in on that as well. And then to me, this is the big one, that lab notebook. That is the consummate tool that you're going to be working on. And I'm sure those of you who've been in the business of teaching biotech for 3 to 5 years know it's a never-ending work in progress. But you get a chance to hear from us what we think are the key elements of these. And once again, please keep in mind, when we put this presentation together, we're using that lens of, probably a teacher in their first 1, 2, or 3 years and what they would do to be the most successful in those first couple of weeks. Okay. And who was ever driving? Maybe next slide.
That's me. So for those of you who joined us more recently, we have a Google Hyperdoc. You are welcome to hit this up with your phone. However, I'm going to put the link into the chat. Callis, do you mind if, do you have that link? Let me see. I'll put the link in the chat in a minute while Stan and Kirk are introducing themselves a little bit more. So you can click there. And the goal of this is to have a place where we can all kind of communicate, share ideas. So during our Q&A session earlier that we just had, we had some questions, and we encourage you to provide answers too. So I'm going to make a copy of this because we're going to need more room for Q&A here, I can tell already. So if you have questions, you can put them in here. You can also just type them in the chat. I'm trying to capture things in this document as we go so that this can be something that you can refer back to. There's a place for Q&A, there's a place for notes, ideas, and we have links at the bottom here. So please feel free to use this. You can edit it. Let me go ahead and put that in, but I'm going to switch back over here first. Actually, let's go. Let me get that link. I'm sorry. Give me 1 second. I've got to go here.
Lee, I went ahead and put that in the chat. Is that what you're
excellent. Thanks so much. I appreciate that.
Okay, got you covered.
Okay. All right. So now we can do a little bit of fun here. We're going to do some Zoom annotation. So I don't know if you're familiar with this or not, but you should all see something that says like Lee's screen or Lee Brown's screen up at the top, right? And there are these 3 little dots in a circle. If you click that, choose annotate. So go ahead and do that now. And then on the toolbar that pops up, sometimes it's on the like the side and sometimes it's at the top. It just depends, I think, on how you have your screen configured. Find the check mark. And then that is the stamp tool. And so you can click on any of those little tools right there. So there can be a check, an arrow, an X, a star or heart or question, right? And then you can click on my screen or on your computer screen and it should start adding things. There you go. You got it. So yes, you got it. Awesome. So this is a way, this is one of those tools that we learned during COVID, right? Because we learned all kinds of crazy stuff during COVID that, is kind of helpful now. But this is a good way that you can have your students be interactive, or if you're doing a presentation for other teachers or whatever, have a little bit of interaction. If you wanted to type a text here, then you can click on the text tool, okay? And that will enable you to type out something. So I'm gonna have you type in a little bit here. And then most importantly is to stop doing all of this stuff, this annotation business, you have to click on the arrow tool, like the cursor one, the top left or the top one or the far left one. As an instructor, now I can also, I don't know if you guys are going to be able to see this or not, but I can clear all your stuff off with just a little trash bucket on my side, right? And so I'm going to do that now. I'm going to clear all the drawings and we're going to go to the next, and now I have to go back to the mouse tool. We're going to go to this slide and y'all can all go nuts for a little bit. So if you want to practice here, go right ahead. There you go. And you can turn on the names on or off. That's, if you wanted things to be anonymous, that's fine. I probably meant to turn it off, but Kirk, that's a pretty impressive start. I like it. Okay, I'm going to clear all this off. So hold your clickers for a second. And now we're going to go and do a actual poll. Where do you live? This is an easy one. Start off easy. If you're outside the US, if you don't mind typing it, that would be great. I started off with a world map and then we were like, I think we're gonna have too many people piled up in the middle here. And I'll put where I am on here. I am right on top of Jennifer Lazar. So right in Central Texas here. All right. Still letting
kind of east
go. Great, great.
A couple California, Kirk.
Yeah, some Californians. Amy is off in the ocean somewhere. I love it. All right, we got a good mix. I'm gonna leave it up for just a few more seconds here. I like doing this so that you can feel not as alone, right? Too. I think biotech in general is a pretty isolating course because oftentimes you might be the only one in your school or sometimes in your whole district that's doing biotech, right? And so through this, you can maybe see that there are other people close by. We're always just an email or a Zoom call away too, but yeah, so we've got people all over the country. That's fantastic. Callis, do you mind taking a screenshot? I always like to see where people are from. And let me know when you're done so I can move on to the next one.
All right.
Thank you. Thank you. Okay, next question is, let me clear you off. Hold on. Clear all the drawings. There we go. Are you currently teaching biotech? Some of you may not be yet. Some of you might not even be interested in teaching biotech. You're just kind of curious to hear what's going on. Some of you might be kind of new, more experienced. If you're more experienced, put in the blue there. You can type in how many years you've been teaching too if you want. So that works too. I love the drawing. Y'all are much better at this than I am. I cannot draw with my trackpad to save my life. And we've got a great mix in here. Okay, so we've got a lot of people just kind of gathering ideas. We've got some newbies, we've got some experienced people. And so that's really great because when we have questions, some of these experienced people will be able to chime in with their experience too, right? So that's good. Okay. Jennifer, I would say you're a experienced biotech teacher, even though you're not currently teaching it. Okay, so do you mind taking a screenshot of this one, Callis? And then we'll have one more question, and then you can rest your clickers. All right. We good? Got it. Clear all drawings. Let's go to the next one. What are your 3 biggest challenges? Okay, and try to pick just 3. And if you have some that aren't listed here, go ahead and write those in. So I tried to think of all of them, but money.
Money.
That's a big one. I didn't put budget on here. Oh my gosh. Yeah. If you wanna ditto Yvette's money, you can just put a star by it.
Time and money.
Time and money, always, right?
Time and money.
I kind of tried to break time up, like what in particular about time, because there's a
Exactly.
lot there, right? It could be lab prep, it could be curriculum, it could be your own training. So, and by PD training, I meant your own training on biotech, right? So that's sometimes a challenge for people. Logistics, time.
I would even qualify that a little bit more and just say, I need to develop more in my confidence in teaching this content. That's kind of what we're after with training.
Yep. Yes, because sometimes, we might have done something in a college class, and that was 2 to 20 years ago, right? And
or not at all.
Or not at all. Exactly.
Yeah.
And so getting that confidence where you, and prep is a big part of that too. You might have done a lab in a workshop or a webinar or in college, but you didn't prep it. And so that's a big piece of this, is learning how to do all that, right? Wonderful. Okay, I think we're ready to screenshot this one. And then I will clear you guys out. Actually, before I clear you out, go ahead and switch to this, that little top mouse icon, the arrow icon, either the top or the far left. And that way you won't accidentally click on stuff. I say that, and I know someone will accidentally click on stuff, and it's going to be okay. We can always clear it off. But okay, I'm going to clear this off. And now, Kirk and Stan, I'm going to let you introduce yourselves. I should have moved this up all earlier. Sorry about that.
Yeah, so I spent the last few years of my year and a half of my time in Washington, D.C., helping think through the what should be in K-12 experience for kids when they experience the Center for Advancing the American Dream across from the White House. Prior to that, I was for about 10 years, I was the division director of accounting in California, the largest in California. We have about 28 employees. We have facilities in 3 different cities. We do all kinds of cool stuff. But for 25 years before that, I taught at the same school the entire 25 years, when only about 35% of the kids go on to, or even qualify to go on to a 4-year school. So we never had a prerequisite for any courses that kids took. They could fail every one and still be in the next one. So we had an incredible diversity of students, from students that mom and dad picked fruit in the field, and the same sitting next to the child of a student that was a PhD scientist at Lawrence Livermore National Laboratory right over the hill. And so the diversity, it speaks to me when you say that your students are not prepared, right? Some are, some aren't. And so I thought, well, if you're going to experience and learn something, having a skill that you put on that you know how to do, you put on a resume. Because remember, photosynthesis test taking is not, you would not put that on your resume. So I think that's when we've overemphasized students' achievement on things, it really affects their ability to have confidence in doing things. And I think they have a hard time connecting the dots. So that's enough for that. I'm retired right now, semi-retired, which means I'm doing a lot of other things like you all on these days, doing some cool things. But I think what's missing in our society in education, especially science education, is the connection to mentoring. And I think I'm trying to get that changed right now. in my local region. It's like, how do you bring the expertise to the teachers that need it most? And I think this is what these kinds of discussions are about. And we often we reinvent the wheel over and over and over again ourselves, and that is not a good strategy. So I'll let Stanley introduce himself and we'll move on.
Okay, yeah, hey, big thing is I've worked with Kirk for as long as I've taught, an awful long time. I was a classroom teacher and administrator for 30 years, just recently retired. I think the pertinent thing for me in relation to you is that I got started with biotechnology really early, back in the early 1990s. And I was doing that at a point when my colleagues with them, and by the way, I was really impressed. Under the list of challenges, I don't think we had any, maybe one under colleagues. That's great, because it was a little different for me. When I first started going in and bringing in electrophoresis and transformation and PCR into my biology class, I was kind of challenged. Like, why are you doing that? That's not biology. That shouldn't be in the program. So if you are having those issues, I can relate to that. I currently work over at Lawrence Livermore National Laboratory. That takes up a lot of my time. And what we try to do there is try to take emerging technologies and make them as available as we can, as quickly as we can, to teachers. For example, this next week, I'm giving a workshop on CRISPR and on artificial intelligence. So that's kind of what's priming my activities these days. I'm happy to see so many of you guys giving up your time, but Kirk and I both know that's what teachers do. They are, willing to put in that time to improve the quality of education for their students. Okay.
Absolutely. Okay, let's see here. All right.
All right, now for the stuff. All right, so once again, please keep in mind that we're talking through the lens of the beginning teachers and what they would do at the start of each year. And we all know that as teachers, your next year really begins before the previous year even ends, right? So hopefully by now, you've already done some of that front loading. But what I'm talking more about now is the kind of the skills and tools that you might want to look at in order to make that next year get off to its best start. And the key to this, and you know that by now, those of you I saw checking off that you've been in this for 3 or more years, is its organization. It's really knowing what's coming up and what should be on your radar screen. And one of the things that I love for organizing is our checklists. And I don't know how many of you have seen Dr. Gwandi's videos or books, but he makes the claim that as human activities become more complex, the more, things like landing a 747 or launching the space shuttle. When these very complex activities come about, it becomes important to use tools like a checklist. And aren't you glad that there's this redundancy built in, and the pilots are asking, landing gear down, flaps down, as they approach, and they're going through that checklist. I would have to, oh, by the way, if you search online for Dr. Gwandi, you'll see some great videos on checklists. If you're interested in more information, he has done at least one TED Talk, I know. So that's a great resource. For me, I was less a checklist kind of guy when I first started. I think I was closer to Maverick in Top Gun, kind of flying it, winging it. And but it didn't take very long. Thankfully, I didn't have any major disasters, embarrassing moments, but I was scrambling a lot. And as it became more complex, I realized I need to have some tools in place. So one of the things I've done here is I've put up on the screen just a sample of a checklist that would be of great help to you who are starting. It's a biotech teacher to do checklists. It's outlined by the month. It has major activities. I'm not going to go through all of these, but if you want me to talk about some of these later on, I'd be happy to do that. But I will take us up to May and June, which is when most of you guys are, taking care of your inventory, getting your purchase order submitted. I put 2 stars. If you take a look at that, 2 of the things I learned really early on is, hey, stuff gets delivered during the summertime. And where does it go? And do people know what to do with it when it comes? And, oh, by the way, a lot of the stuff that you're using is temperature and time sensitive. So I will admit there were days when I was over at the district warehouse waiting to see if a certain order had come in yet, so I could make sure that it went immediately into the freezer so that it wouldn't be destroyed. So lessons learned about that. I got to know who the warehouse foreman was, what his name was, his cell phone number, all that type of thing. It's important. And I think I saw a lot of you check off that recruitment is an issue for your courses. And that cannot be more so than if you're teaching your first 1, 2, or 3 years, right? Because your school will not float a class that has 3 to 5 students in it. Okay, that's just not going to happen. So I put an asterisk on this list that it's really good to know the counseling department, get to know them, because they can be your advocate. If there's a new student who moves in the middle of July, and they know that you need 2 or 3 more students, they could kind of offer up, hey, have you ever thought about biotechnology as a course? And I know in our district, because I was in charge of math and science for a district for 4 years, counselors are instrumental in keeping our fledgling new courses afloat by seeding those courses and helping. And once again, they'll be your advocate. So that's really important. And I think lastly, the good thing about checklists is if you look at the list, by doing the things on that checklist, you're going to avoid a lot of what I call course corrections. Oh, sorry, the test is not going to be today. I didn't know we had a day off that day. Oh, shoot, this lab is a 2-day lab, so I'm going to have to move it. Well, those are the kinds of things that are going to get your students to lose confidence and question, how things are going to go this year. So it's really important to go through and make sure all that is in place, because that really, in the end, is your reputation. And your reputation as a teacher and your course is what drives enrollment. So early on, if you happen to be a new teacher teaching it for the very first time or your first couple of years, organization. Can't say that enough. Kirk, did you want to add anything on that? Oh, muted.
Nope, I chimed in on that. I texted about how this helps with stress. So the more you organize you are, and the more you share those strategies with your students, and they see the benefit of that, the more they will embrace organization as a key component to their stress reduction.
Great, thanks. Okay, next slide. So we're going to share a couple of tools. This is my tool. This is my calendar. And I am very visual, as you can tell. This is an actual shot. I took it just the other day of my calendar. I color code absolutely everything. This tends to be my personal calendar. In a second, we're going to talk about curriculum calendars. In these colors, I've got blue. Those are Livermore lab activities. The green, Bio-Rad laboratories, right? Got the green. Pink tends to be the school-related activities. And yellow tends to be the family, my personal things. And orange is like, really recognize this. We were flying down to San Diego to see my niece graduate from UC San Diego. So that was orange. The cows, no particular reason. Those are my holidays. And I put those on there. And I do keep most of the curricular calendar type things separate, but I do put those important things on this calendar, like back to school night, final exam week, those things that are going to be a big impactful thing. But when you talk about color coding, I do it throughout my entire life. Here is a sheet. Like I said, I'm teaching CRISPR next week, and it's color coded. And I keep different colored markers, different colored pens. I know this to my friends at Bio-Rad, kind of do the same thing. Love color coding. All right, next slide. This is Mr. Brown. Take it away.
I was just responding to one of the comments about where to get materials. I think that's really important. But this book is, I have one for every year I made this, because what didn't work for me was a particular way of doing this. So I made one myself, right? Because I never taught less than 3 preps. My biotech class had technically 9 different courses inside of it. The way we had to take attendance was like a bear. So I organized myself in such a way so that when I took attendance, for instance, I had a book that had all of the kids that came every day of the week, their picture, because I can't spend half of the class trying to take attendance and trying to record things and trying to do all that. Yeah, we have to do it because it's a safety thing too. You gotta know who's there, right? And so things can occur. Notice that this is not a lesson plan book, is it? It's really just showing me it's a course outline. It tells me what I'm doing, right? If you're going to give a lesson plan to someone else, giving them a handout or giving them this is not a lesson plan book, right? And so I think when you think through that, that's another thing we could do. And another follow-up is, how do you share your teacher moves with somebody? Because you can tell them all the things. You can give them all the handouts and the answer sheets. It's still not going to allow them to teach it like you. It's not going to show them what you do, when you do it, how you do it. So I think that's a different purpose. And so I hope you don't have to write out those kind of lesson plans for every lesson you do, because that just takes an incredible amount of time. But in doing it once or twice, it does help you really make sure that you don't forget things. It even doesn't forget. How often have you taught a class and taught something I want to say this to the students? You get caught up in everything and you don't, right? Because you're thinking, oh, dang it, I wanted to tell them this. I wanted to remind them to do this, right? We often use our whiteboards for that, where we'll say, don't forget to do blah, blah, blah. But even if you don't point it out to them, they are so, mired in things to do themselves, they'll forget to look at those things. So I have a code system so that you can see it Monday, Tuesday, Wednesday, Thursday, Friday across the top. And then as you go down, those are the preps, right? You'll see biotech in the first row. The second row with Advanced Biology 1, I taught IB, International Baccalaureate. So I had those students, and some took only that course. Sometimes they're seniors in there. All the Advanced Biology 2 students were the second year higher level IB students. And then some had biotech that never had any of those courses, right? So the diversity of student that I had was something that at first I was frightened by. But in the end, it turned out to be good for everyone. It turned out to be good for the students that were there and all of the other possibilities. So we're going to walk through a number of these kinds of things. I wanted to show you this. I think I went to Staples and had these spiral bound. They weren't very expensive. I had a clear cover put in those, and I photocopied those on cardstock. So when I wrote those, I always wrote in pencil. And the reason I didn't, my calendar that Stan had doesn't look like his, because I was always afraid to color code mine like Stan, because I changed mine all the time. When you look at mine, same thing, but I had a million different things. And when I finally got to the point where I couldn't possibly write any more on there, I started using a calendar like that to move digitally, because I could set reminders. I could forward due dates and backwards plans. So I always showed those to students. They adopted that, and they were started doing better across all of their subjects because they could manage that. So Stan mentioned organization is no small thing. It's probably the one thing that will make you stay teaching these subjects longest, is if you can get yourself organized, write notes to yourself each year, what went well, what didn't, what new labs you want to bring in, and where the students are out in that achievement. If the students come back to you years later and say, oh, wow, that really helped me, I could do blah, blah, blah. Those are the proof you're looking for, right? Students going and saying, that really allowed me to be useful in college, not the fact that they got a grade, right? Because this emphasis in grade achievement is potentially cancerous in some regard, because then they get a grade, but they don't understand anything, right? And I don't know if that resonates with you all, because you get students that wanting to achieve certain things, it can really be a problem. So I've experienced that myself in a number of ways. Go ahead, Lee. So in starting your class, right, day one, right, there's things that you have to do day one your district wants you to do. So whatever you see and think through, like when do you go get your books, puts a kink in the works, because you sometimes have to take your class out of the classroom and go there. So this first one, we had to go over the class syllabus with them. we did that, and I started doing everything online for the most part. And often I would just say, can you read through this? We're going to move on, right, and go do something else. But that just depends on what kind of students you have. These students were very engaged in this. They were so ready to roll. It was exciting to see. So the lab orientation is what we did first. Now in my class, this may be different than yours, and you may not want to do this, but I made them take things out of the cupboards and put them back in the cupboards. I did not get out a bunch of stuff ahead of time because I felt like that was a missing opportunity for them to learn to put things away, to have a checklist to say, remember, 5 minutes before, I got to get my stuff in my box, get it back in the freezer to do that. And so when I first started, I had one single gel box that I embedded inside of a class. I had like, I don't know how many lanes of acrylamide gels. I used a 5% TBE, trisborate, EDTA gel that I could load DNA samples in. You know what? I had a student, one, just so happens, she spoke at the Stanford graduation. And you know what she mentioned? How important doing electrophoresis made her feel smart. Guess what? We had one pipette, we had one gel, and we all shared that. That was it. She didn't say, oh God, we only had one gel and poor me. She said that was it. That inspired her. So there's so much, right, that you will assume they need X to get started. My advice to anyone is to say, do what you have. Get going. Be excited about it though, because that's what I did. I said, this is so cool. We're going to figure this out. And then we could take one gel picture and then do all kinds of other stuff with it. And that's just important. So we needed to really do these safety orientations first, right? So first day, we walked around looking in cupboards, take things out, and it was made for that purpose. So there wasn't things in there that they shouldn't, touch or get used to. So we wanted to make sure they knew where the fire extinguisher was, where the eye wash station, how to use it, right? I told them, I make them laugh sometimes. Don't half put someone out there on fire, right? Don't say, oh, I don't want to get the floor wet. Oh, I don't want to get the floor wet, right? By the meantime, they laugh a little bit about that, but in reality is these machines in a time of use, you need to know how to use them. So we really went through all these things. I told them funny stories about me, drenching myself in the custodian, trying to show them how to use the deluge shower. It works good. Deluge both of us, right? I was sopping wet when first period came in because I had showed him how to do it. It really worked. So the more you can do things like that, the more fun it is, right? So that's something we did the first day. And where is things are stored? Like, where are your boxes? Where are your tips? Where are the things? So after they went around, I would have them tell me what they did. So that's day one. So most time people spend all their day going through that stuff. Day two, we had to go get our books, right? So we would go get the textbooks. Then when we got back, we actually showed them how to wash their hands properly. And in doing so, this is one of the things that we wanted to make sure that the students themselves knew how to do, because we wanted to make sure that they know how to put gloves on without contaminating themselves, sticking their finger down behind the glove and get this, all the things they tried to prevent themselves for, they just contaminated themselves. So that's important. When to use PPE all the time, right? I was adamant about that. Is that do not take your safety glasses off until you're away from where that is, because it's not yourself that potentially is going to get you. It's the person across from you that's going to flick something that's going to land in your eyes because you took your safety glasses off. So I told them, even if you're going to wipe them off, you have to take your gloves off, pass out, move out to the center of the room, get away from everybody else, then do it, then go back over there. So that's important. Oftentimes the kids don't have their lab books here, the notebooks where they write in there. And so some schools have digital notebooks that they use. Some have, handwritten notebooks that they use. We always did that. We had donors that would donate that. I told the kids themselves, if you can't afford it all, I'll do it for you. And so you wanted to have an industry standard research notebook that they could actually, sign the bottom of each page, to and from pages and all that stuff. And that's what the notebook rubrics are there for, where they rate themselves on novice, developing, and proficient. And there's actually there's 10 categories, each one being 3, so 30 being the maximum, right? If they were proficient at each one, they do that. And I start out easy and I work toward becoming more picky over time. What's interesting is the kids had to self-assess before I would even look at it. And so, and never in biotech, and this is one of the shifts that we were talking about earlier, I didn't do it like a regular class, which in your IB classes, your AP, or those kind of things where you do a lot of quizzes, a lot of formal things. This was much more open, and the students would self-assess, and I'd say, well, oh, I didn't do this. I said, good, go change it. You know, they were like, I can't mess that up. It's in pen. I said, yeah, it's this pen. One line through it, rewrite it on the top, right? If you didn't add something, go to a forwarding page and redo it. Because if they're going to do it that way, then they know they're in control of how they learn this. So lab orientation and safety cannot be underemphasized. All labs in the United States are considered BSL-1 labs in high school. And so you need to make sure that you're following that. And that's something that I don't know if you all do that, but it's really important to think that through.
Hey,
okay. Yeah. Kenny?
Yeah, I just want to chime in. I think new biotech teachers, the one thing they may overlook is just how many gloves you go through. That is, to some people, startling. I mean, literally, you could go into the thousands of pairs of gloves in the course of a school year. So make sure you got plenty of that available right from the start. One strategy I used was, at the beginning of the year, everyone bring in a box of gloves. Okay. So, it's at the beginning of the year when you're asking for donations and things like that. Sometimes, parents are tired of, I just cut $100 check, but asking for each kid to bring a pair of gloves, maybe at the start of each semester, that'll really help defray it, because gloves are not cheap.
And one of the things about gloves, and it took me forever to realize this. I went down to a local hospital one time and talked to them, and they said, "Oh yeah, we'll donate all gloves any you want." And the downside is a pallet full of gloves came in a semi, and the school had a heart attack. Right? Like, what in the world? And it's like, well, I had gloves shoved in every nook and cranny all over the campus, right? And so, but I didn't have to worry about gloves anymore. And the community, they love to do that. Right. So lab coats, they donated lab coats. Another graphic artist developed a patch that we sewed on our lab coats. And I had 3 different colored stars. So a third-year student had 3 stars, a second-year student had 2 stars, a first-year student had 1 star. And then when they walked in, they needed some help, especially a principal walked in. I said, always look for the 3 stars. If you have someone available, they're the ones who've been here 3 different years, and they're in charge of a group of students. So this mentoring environment I cultivate over time. At first, I didn't have that at all. And so everyone was a single star, which was a good thing. So when you look at day 3, now we really get into the lab safety and how to make sure, because remember when we were just chatting about students not having had chemistry, that's where you usually learn a lot about how, chemical safety in a big way. We have a very comprehensive chemical safety training program for kids, making sure there's in California, you could be inspected anytime. And I wasn't afraid of that. It's just that, the kids need to be trained, and you need to make sure that they have achieved that training. And that's because that's also part of industry. And I've learned that about the biotech companies like Bio-Rad, what we've worked with, and Lawrence Livermore Lab, we had to pass classes and all these other things. So they might as well get used to that, thinking through that you're there to protect them and their colleagues and yourself at every moment, right? And so that's important. But I'm telling you, they loved when I'd have one of my former students that worked for a gas company. He'd bring in a Dewar flask full of liquid nitrogen. The kids just had a ball with that. But we also did dry ice. We talked to them about carbon dioxide, the density differences. So it really puts a fine point on what you're experiencing. So if you can do that with your kids, that's important. If you're using antibiotic resistant plasmids and making sure you're disinfecting and destroying those properly. One of the things that Stan and I mentioned, we could do another class, a small workshop about making a suction device, right, that bubbles it through bleach water, so that when you're taking the supernatant off a bacteria you've grown, you're bleaching that first and destroying those bacteria and the plasmids that they carry. So thinking through that responsible biotech is important. And then autoclaving. I don't know if we'll maybe show of hands or someone, if you have a thumbs up, do any of you have an autoclave? And if you do, I had one over time, but I didn't at first, right? Do you have a microwave? Do you have one big enough, right? To have a whole 1 liter flask, right? Those are hard to come by these days, big ones, right? How about surface sterilization versus doing some studies with that? So I don't know if you've all used the whole Instapots, but Stan and I we used a big Instapot where I autoclaved 500 ml flasks. Those were great. I mean, just great. Versus, I think I would go back and taught that again. Now that these Instapots are so nice, I might put one every other table and have them use that. It was cool that kids could do that. So I don't know if that's something. If you don't have an autoclave, I'm not saying it's a good. They're really awesome. I mean, I'm telling you, I bought autoclave tape that turns black. The sterilization tape works great, and it works. You can pour it out aseptically, and you can see nothing grows on it, so it works. So something to think through, right? I actually would go down to the local community college. I knew those people, and I would just make the auger there and sterilize it, put it in the fridge, and when I wanted it, I would just microwave it. But big microwaves are hard to come by these days. So Bio-Rad has some really great resources there that they can talk to you about. So anyways, then making sure, this is very important about closed containers, right? It's a safety issue, but kids, if you're going to let them microwave their own auger and pour it, you need to make sure you emphasize closed containers. Do not heat to something closed. So these are just important skills that when you're in the lab, right? They're darn near 18 years old. When they go from there, they could be working with some pretty dangerous things in college. So we want to do that. Day 4 and 5, we already start the lab math, because if you can't, some of the early solution making is important. So this young lady, look at this. This young lady, Natalia Monica, she just graduated for MD PhD, and she's a new mom. And this group of students, my last group of biotech students, 4 of them are actually are finalizing their MD PhD programs. They've already graduated with their PhDs, and they're doing the next phase. So I think when you think through what can you give your students, you give them the confidence to do things that they thought they couldn't do. And these skills are really important, right? And so notice how she's cross-canceled these things and done stuff, right? And she's written it out. And these are the kinds of things that they're signing. They're signing, why do you sign that? They're saying, you're putting your reputation on the line, saying they did that in front of you, right? These are important things that kids don't ever get exposed to anymore. And so I think this might be something to think through. Giving the kids opportunity to show you stuff are important. And then as they go through this and they get better and better and better at it, over time, you want to see improvement over in their lab books. And boy, they too. And I could talk to you from now until tomorrow about students that have done this. And when I retired from the county office, one of my students came back and she brought her 3-volume set of notebooks. And she actually, as a freshman, competed against all students for an NIH scholarship, and she won it. And she brought that to Washington, D.C. and showed the interviewers that. And she won a job at the NIH in the summer after she graduated. So, and remember, we're from a school, not a public school, in the middle of the Central Valleys compared to the Appalachian region of the world where kids are really struggling, right? And so you don't have to be from the most, high-level students. And where Stan worked and where I work were 2 different places, drastically different. He was over in the Bay Area where students have that. And so to this day, the program in Central Valley of California, we offer a biotech class for all students in the region at the county office. So they can come and do a 3-day class at the middle school level so that they can go on and kind of think through if their school can't do it, regionally they can. So there's a lot of potential to think that through. Okay, go next slide. All right, so in this case, lab math can go on forever and ever. Don't let it, right? Just make sure they're experienced, make sure they know how to do it. You can show that, they can look at it all the time. They can actually have their notebook out and turn back to examples and follow it. It's no big deal. Give them easy things and let them get started. They always had to do stuff in the lab notebook. The reason that lab notebook has all the calculations in there, and the Bio-Rad notebook, I'm not sure what book you use or if you're going to use one, But the reason I did that is I thought, well, I don't want someone to have to go through all of what I did in order to get to this point. If we can show them how to do that, then they can actually figure out how to make a certain solution. Then they can dilute it. Then they can do a compound solution. Then they can do a compound dilution. Once they get enough experience, they get good at it. And they start being less stressed out about getting the right answer and more confident in their ability to think their way to the answer. Make sure you ask your students regularly, are you thinking your way to the answer? Or are you trying to find the memorized answer in your head? Where is it? Which one are you doing? And so often they will, and if they give you an answer on their lab math, it's 3 decimal moves off. They're not thinking that way to the answer, right? So if you have yourself where you're talking to them about that, that's where your affect, your ability to keep calming them down, keep confidence building where appropriate, it's important. You don't want to praise them when they don't deserve it, because they'll think you're just telling them that to make them feel better, right? You got to look for ways where they're showing great improvement. I would actually talk to them about their lab notebooks, and I mean, some of them are just beautiful, right? They're just great at it. So the more you can do that, the better. These pipettes, how many of you use all 3 of these? The pipette, the tri-bulb, the syringe style pipette pump, and the electronic one. Some of them don't have that. You don't have these 3, but sometimes you go to a university and they only use the tri-bulb, right? So don't forget that even if you have the ones that are these fancy ones, don't, right? Try to show them, and if you have one's enough, right? They can go around and have some experience with it. So that's another thing. We can even show you how to use a mechanical Eppendorf repeating pipetter to another time, how you might utilize those. We are lucky in California. We've got the biotech industry has a biotech giveaway program where they get for free. You can go there and get everything you want, as long as you're in a biotech, in a school setting. And it's just great. So anyways, showing them how to wash containers is the very first activity. So that's one of the, other than washing your hands and writing that in there, that's one where they write when they just write it down. By the time they get into washing the containers, this is where they really write everything down. So what happens when you write everything down as you do it? What does that do to your time? Write in the chat right now, what do you think it would do if you say you have to write it as you do it, step by step? What does that do to your lab? I'm waiting to see. And you're in the chat. Show me, what would that do if you had the kids write out as you go? Yes, it slows it down. And the slowing down is the reality of things. If you tell them to skip over that, they're not going to do it right? So you have to get used to them writing it down as they go. So biotech only classes can't be governed by the speed of what you got to get to the next activity. You got to get to the next activity, because if you do that, they're not going to learn how to write their labs as they go. They're not going to have corrections and things like that. So you might think that through and say, maybe that's another thing we can chat about over time, but you have to do that, because that's going to be the evidence that they're going to use to show the people that apply to lab, to get a job, a part-time job. And these are all strategies for them to actually have something to say when they're interviewed about what they've learned. All right, next slide. Okay, this is where we start making solutions. And so remember I told you there's they had a checklist of what they do. And they want to make sure that they've labeled things properly with what it is, the concentration, when it was made, who made it, right? And then any risk factors. So this global harmonized system of symbols are required, right? That they have to add any hazard to them. So I would have these around, the kids cut them out and tape them on the side. Most of them are all temporary solution storage, but they store it out. I have a gazillion reagent bottles that they would put this on there. And then they would kind of have the edge bent over on this. We use blue tape on the whole roll dispensers all over the lab. And the kids always did that. And it was just great. And the students got really good at this. But the first time through, maybe not so good. Second time through, you're showing them, show me. When they're going to assess them, you say, show me how you made this solution. I want to see your calculations. I want to see step by step. I want to see every unit, every cross canceling, so I know you did it right. then show me the bottle and say, great. Now, one thing that you might think through about grading kids is this is another one of those shifts that Stan mentioned. And that this, yes, they fill in the blanks is I see someone mentioned about fill in the blank style can slow labs significantly. They can. I just think that one of the things you might do here is when the students are thinking about everything has to be assessed, I stop that right away. Now, 1 out of every 3. I do it in chunks. Every 3 labs, we assess them all. I write every single one down. 1 gets recorded permanently. The others get exempted from. So that way, all of a sudden, that's designed to lower their affect, right? Oh, no, don't worry about that. Don't worry. You can look crunchy and messed up and a bunch of corrections on pins slashing out. It's okay. There's no score in there, says that. But over time, the kids get better and better and better. And they do it because they know that they feel like, wow, I mean, I'm not getting hammered on every single thing, right? You want to make sure you think through how can you build the kids' confidence and show that they're improving without just saying to pummel them on everything that they're doing along the way. So that was a game changer for me, right? Have just them self-assess, meet with me to confirm, and then, okay, great. If you want this recorded, well, we'll record them all, but only 1 gets put in the lab notebook. So after all these activities, they would do that. And I'm telling you, big game changer. Okay. All right, next one. Okay, so the lab practicals. We mentioned the idea of testing and getting ready for the base exam. So look at this. Remember this when you're in school? Right? So I did just like when the old school days. And so when you're training kids to know stuff, right? Here's one thing you do. Okay, show me. I hold this up in the lab and say, what is this called? And they would say, Eppendorf tube. Nope, say it with me. Ready? I'd say 1.5 milliliter. And they say, all repeat after me, 1.5 milliliter, right? Flip top, microcentrifuge tube. Oh, good. Okay, what's this one? It's a 2 mil. Okay, flip top, microcentrifuge tube. That sounds silly, but in reality, kids that come from other countries and things like that, once you lose, we're not kidifying it. We're just teaching them how to do it properly. You have no idea how many times kids would come and say, thank you for doing that, Mr. Brown. I always felt guilty asking questions like that. So the more that you from a region that has a heterogeneous population of kids, they might speak at home different languages. When they come to you, they need that confidence builder. So the more that you can show them what to do and how to do it, the better. So lab practicals were like that. They're little 3x5 cards. I laid out. I went around. They sit out in the lobby right before when it's time they came in, sat down. You can also just have it set up, put blankets over it or something when you're ready. Okay, go over, undo it. Okay, you have about 2 or 3 questions. Make sure you align your answer sheet. And these are 1 or 2 word statements, right? Go bing, and they go around, and they get to the start again, done, and then good. And if you have more than 1 class period and they come another period, you just change a few of them out of, so they're not just memorizing what's on station number 3, right? You change them out. You just flip them on the other side. They may have a different order of questions, so they couldn't, cheat. I mean, most kids don't, but every once in a while, someone will. But that's fun. The kids love that. They thought that was great. It's like something if it's a microscope or whatever you're doing, a calculation, it could be anything you're currently studying. I would do those once or twice a semester, just for fun.
Kirk.
I think these should be free points. Ken?
Yeah, I agree with Kirk. My students love lab practicals, but as an administrator, I've learned that lab practicals could be the place where if you're not encountering any classroom management, that could be a problem. It's a different activity. It's a different vibe. So it's really important to have high expectations, set the kids up for success, because teachers that don't look to that aspect of it, that first lab practical could be a little bit of a mess. So by all means, do them. They're so exciting. They're so much fun, but make sure you understand that, if you're having the kids stand outside of the classroom, they're going to be in the hallway, in some cases, indoor hallways. And other teachers are complaining your kids are screwing around in the hallways or things like that, or they're talking. If you don't set up the expectations like we have here, there's no talking during the exam. So if you set up good expectations, then the kids will have a great time.
Yeah, and when you're talking skill development, skill's different. If you have a course like a CTE course, when you're developing the tools of the trade, it's repetitive use and multiple exposures, and then giving kids control. It's important, and not everyone has to take something, so to the nth degree, right? They should be where they're at and where their skills are at, and they should be growing from there. And I think that's important. So when you look at these traditional shifts, right, emphasizing the skills, right? That's what my purpose of this was about, right? Not trying to do conceptual understanding of the things. That's for other parts of it, but also the book. Notice the book that I have facilitated really is about just enough content, and it is complicated. So it depends on what your students can understand. But giving them a ginormous book that's like got everything under the sun, they have to wade through that. That's difficult. So I tried to pare it down to the amount that they need in order to understand the labs you're doing. And then these build over time. So the skill attainment. I know some of you are not teaching biotech, you're exploring. So one way to get started on that and get the kids thinking is that at the end of your regular lab book, either in chemistry or biology, have them at the end of every lab pull out the skills that they would put on their resume that they learned during those activities, and write it in the back, a list in the back of their notebook. Because if they keep track of all the things they could say they know how to do, right, and maybe they've only been exposed to it once or twice, we'll say that. Don't say I'm an expert at it if they've only done it once or twice, but they at least know when they've done it, right? If you do that in those regular classes, that's what keyed my students that kept asking me to teach biotech. Can we just do that like a full-time class? I promise I won't skip another class to do that, because I would say, no, you need to take physics and chemistry and those other classes. They'd say, well, if I do that, will you let me just teach and play with biotech? I'm like, sure, great. In the end, they think that your ability to learn concepts is the same as your ability to learn skill. And I would argue that skill development is by direct instruction. It is not by discovery, right? It's safety issues in there, right? So direct instruction has a place in science. Oftentimes when you think of NGSS and student-centered learning about attaining concept development, that's a different thing. So I think one of the things to think through is like, be careful trying to make your course both, right? Or at least not concretely say, oh, remember, this is a skill. We're going to show you how to do this properly, right? And then when we get into big idea attainment, that's different. So that's important for students to know. When am I shifting to discovery, the big ideas and building on that over time myself, or when am I actually just learning how to do this properly? So anyway, self-assessment has to be the norm in biotech for sure. I think it's helpful in all my classes too. Many of the things I learned teaching biotech pushed my way into IB as well. And I think in my other classes. So think that through and ask yourself, could you do that in a way that helps you? I think it makes you go quickly. And the purpose of these things were for students to go off and kind of have a list of skills they know how to do, and the courses that they've taken, the grades that they've achieved, and the exam scores they receive all verify the other thing. What you want to make sure is when someone calls you and say, so-and-so has applied to a job for my lab, they say they can do this. They say they can do real-time PCR. In high school, really? I'm like, yeah, ask them. They can, don't ask me, ask them. How did they do that properly? Or PCR, how did they do that? Right? Did they really determine if those things were from Agrobacterium tumefaciens in that tree out there? I'm like, yeah, they did. It took them 3 years. And so those are the kinds of things that you'll get engaged when they start using the skills and telling someone else that they've done that. But remember, don't overemphasize those, because they'll think you want kids to make these great discoveries. I would have kids say, Mr. Brown, I'm really not confident in doing the transformation clearly and myself in extracting the plasmids. Could I make that be my project? Absolutely. And you'll be great at it, So what you say and how you say it affects your kids' ability to do things too. So that's important, because remember, I would tell them, hey, even if it doesn't work out, and you'll get an answer. answer might be no, but you'll have an answer and you have all this data that you've received in biotech skills you built while you got that answer. So that's what we're here for. So anyways, the student-centered leaders, I can't emphasize enough. I've changed the lives of so many of my students to be those leaders. And it could be a second-year student just helping people, right? Turn to them before turn to me. And that's just powerful. So something to ponder. All right, next one. Getting close. I want to make sure we have time to really talk to them. But these discussions here are designed for you to think through. How are you going to teach kids if you don't have a lot of experience? And these videos are what Stan and I did. So that's my hands and that's Stan's voice. And we videotape these in my classroom at Tracy High. And we videotape them. Stan's an expert at this. We had lighting and all kinds of stuff. And they're not perfect, but they're a good use. Many of these have well over 1 million views. And when I talk to students, they're like, oh, they'll ask me questions about my hands and what we did there, what's underneath those, and fingers and stuff. It's amazing. Kids wanted to stand and have our picture taken with Stan and I when we were places. Feel like we're celebrities of the green hand world, but it's a lot of fun to think that through. But boy, I hope that if you haven't used these videos for your classroom, that you do, because this is one of those things that using a flipped instruction where the kids go watch it ahead of time. More importantly, I started having the kids, I show them once and I say, okay, go look at this. I teach a 1-day biotech experience for our STEM masters in our university near us. And they absolutely love this. They watch that video on their computers or phones at the same time. And just great. So think through how you might use these things to help your students. And then when you're, if you don't do this, but having a video camera where you can write down and record when a student asks you a question, you can start putting those on your website. And if a kid has the same question, they can use that. I mean, there's lots of ways to keep going here, but that's really critical. And we find that these strategies are absolutely amazing and game changers, right? Where you can say, what if you didn't have any of these skills? Could you teach a biotech class? And the answer is yes, as long as you have followed the safety rules and you actually use these videos and we're a co-learner with your students and they knew it, right? You're one of them learning co-learning. And some people are confident about doing that. Some are not. Depends on the kind of students you have and how your own, personality would work. But that it's really one of those things to think through. So I think one of the things my career, if you look back at these youngsters here with our colleague, I first learned biotech with Stan when we went to a meeting at Lawrence Livermore National Laboratory over 30 years ago. And we actually started working at the lab in the summer times, and these programs are still available. You can still apply for the Department of Energy programs where you get to work in the laboratory near you. Many of my former students are actual professors around the country. I'm proud of that fact, right? But I'm also as proud of the students that took biotech that went on to other fields. I got this great letter from a student of mine that became a lawyer. And she said, I didn't think I'd ever use this, Mr. Brown, but I really don't have to do too much extra reading to get through all the information about DNA when in the cases that I prosecute. And she thanked me for that. So it's being a parent, right? Being able to answer these things and solutions and safety things. That's what our goal is, right? In science education. It's that for the general population, they understand. But remember, one exposure, I was doing a lot of research at the Center for Advancing the American Dream. One exposure, a word of confidence from a teacher can change the trajectory of a student's life. And I know you all know that. And the work you're doing in these areas to build your opportunities for your students will make a big difference in their life. So something to think through. So Stanley, I wanted Stan to have a chance to talk about his thought. But I think one of the things that we see on a regular basis at the end of our careers are all that work that we do and all that extra time that we take, right? It's the nature of the beast in our career, right? When you do that, it translates into an incredible opportunity for students. And one of my students saw this announcement to this flyer, and she said, Mr. Brown, hey, I'm now an assistant professor at the nearby university that we're partnered with in biology. And her degree from Brown University was in molecular biology. So you just never know, right? That's one little thing you do to students. It doesn't matter how complex it is. It's the fact that you're giving them an opportunity to feel that joy that you feel as a science teacher. That's important. So, Stanley?
Yeah, so thanks for coming. We're going to honor your time. Our time is up, but before you go, I wanted to point out, we'd love for you to take a survey after this webinar. Let us know. And by the way, you know, one thing great about the folks at Bio-Rad is they are really 100% committed towards, you know, giving you everything you need as teachers to be successful. So as you come up with different ideas that we can help you with, there's no topic that's too specific. If you want a webinar specifically on fundraising, I love that. I could talk for hours on fundraising. If you want something very specific, like a webinar on just Lab Notebook, we can do that. So we know you need support. You are the less than 5% of teachers who take on these types of courses. You know, you are truly teacher leaders. You're taking on way more skill sets, way more administrative responsibility. And so we know you need that support. So in the survey, let us know what you need. And I'm sure Lee's going to be happy to put something together, right?
I will. And thank you both, Stan and Kirk. These guys are just heroes, and they are a big reason why Bio-Rad has an education program. So we can't thank y'all enough for taking time out of your day to talk to us and the teachers.